All right, so last lesson we were working with polynomial division. There is also another type of division that we can use, and it's called synthetic division. I think you guys will like this a lot. So when using polynomial division, which is what we talked about in our first lesson, or synthetic division, I just talked about on our worksheet that we must make sure the terms are arranged in descending order of exponents. So if I have an x to the 4, an x to the 2, and an x to the exponent 1, I want to make sure those are x to the 4 first, x squared, then the x term, then the constant, in both the divisor and the dividend. So what I'm dividing by and what I'm dividing into, make sure they're arranged in descending order. In synthetic division in particular, if you're missing any powers as you sort of count down to the terms, you need to place a 0 placeholder. It can be helpful to do this in polynomial division as well, but specifically in synthetic division, we need to put a 0 placeholder for any missing terms. MCM, as Surwa said, most common mistake in synthetic division is forgetting to put a 0. And actually, if I do that in synthetic division, I'll get the total wrong answer. In polynomial division, sometimes we can make it work without having that 0 placeholder. We just sort of line things up properly. With synthetic division, if I forget it, I get the wrong answer in the end. So particularly important that we make sure that any terms that are missing, particularly in the dividend, are replaced with a 0. Okay, so I'm going to show you how we are going to use a new form of division to divide a linear binomial, so degree 1 binomial. This only works if you have a single x to the exponent 1 with some, you can have numbers with it, but the exponent on the x must be a 1. And this can be any degree. So what I'll use is that b value that we talked about in remainder theorem. So when I have x minus 1, I use kind of the 0 of that divisor. I use 1. And what we're going to do is we're going to create kind of this little chart, like so. And what we do is we take the coefficients of all of these x's of the dividend, and we're going to create a row on top. We'll also have a row on the bottom, so leave yourself some space there. And all I'm going to do is I'm going to list the coefficients, and I want to make sure, of course, that my x's were listed in descending order, which they are, so that's good. So I'm going to list 1, which is the coefficient of x cubed, 2, 3, and negative 7. Leave yourself a row of space down here, because we're going to use that space. And then I will put this b divisor value over here. Okay, in this row we add. To get what we put in these rows, we multiply. So I'm going to put a little multiply here. Okay, so first step, so that's the setup. First step is we bring the first term down. So I'm going to bring this first term down. It will be 1. Then after that, we multiply it by the b value and write this product in the next column. Okay, so I'm going to do 1 times 1, and I will write the answer up here. Well, 1 times 1 is 1. Did that one? Now we add. So 2 plus 1 is 3. Maybe I'll do that here. Okay, that's why we have an addition in this column. Now we repeat the process again. I'm going to do 1 times 3, and I will write the answer up here. It's 3. Now I'm going to add. I get 6. Repeat the process over again. 1 times 6. Answer goes up in this column, which is 6. And one last time, add. Should get negative 1. Michael. Yeah, so remember in remainder theorem back up here, we said if the polynomial is divided by x minus b, that's what I'm referring to. So it's basically just like this is our x minus b right here. And so b is 1. We switch the sign there. Okay, we added, we multiplied. We are now going to work our way right to left. This is different than how we would normally read. I'm just going to erase these because we're going to need a little bit of space here. Okay, work your way right to left. This is going to be the remainder. Then we will have the constant, which I'm going to refer to as the number by itself. Or you can put c there if you want for constant. This is the x term. This is the x squared term. Okay, so what did I just find? Well, I figured out that my quotient is 1x squared plus 3x plus 6, and that the remainder is negative 1. So this is the quotient. Once you get the hang of this, it's much quicker than long division. We still need the long division or polynomial division method because I can only use this form, which is called synthetic division, when I have a linear divisor. If I have divisors that are higher degrees, I must use polynomial division. I can't use this method. That's why we need to still know how to do the other one. Okay, so if we were to write this in two ways now, this is quotient form. How would I set this up now that I have my quotient and my remainder? Same as we did in the last lesson. Bella? Perfect. Okay, quotient minus or plus remainder, this one's negative, so we're doing negative 1 over divisor. And how do I do the form to check? Amelia? Perfect. And then if we want to double check our division, we distribute and check. Okay, I will trust that you guys can do distributive property, so we FOIL to check and double check our answer. So still with synthetic division, I have my methods to be able to check my answer and confirm that I've done this correctly. Guys, if you have your mask hanging below your nose, I'm seeing probably like 4 or 5 people that have that. Let's just pull that up, okay? Okay, let's do it again, just to get some practice in here. So we are going to do the chart. This does not work if you have anything other than x in your divisor. So if you had like an x squared, I have to use the other division form. I don't know. It just doesn't. It's a good question. This is sort of like a short form method, so I think like if you have something other than degree 1, it's just not gonna work properly. Okay, so double check, is everything in descending order in your dividend? If the answer is yes, check if you have perfect descending order. So are there any x terms that are missing here? No, it goes 4, 3, 2, 1 constant. Perfect. So let's just write the coefficients of the dividend here. So 1, 1, pay attention to your negatives and positive. This one's negative 7, negative 5, positive 1. What do I put over here if my divisor is x plus 2? What do I need on this side? Kenzie? Negative 2. Okay, so x plus 2, you sort of like find the b value or the 0 of this. It's negative 2. That goes here. I'm also just going to stick in here. This will be multiply, and this will be I add that column. Okay, so first step, nice and easy. Drop the first term. Okay, then we do this multiply process. So negative 2 times 1, write the answer up into the next column. It should be negative 2. Then I add in that column. So as I add here, I'm getting 1 plus negative 2. That gives me negative 1. Okay, repeat the process again. Negative 2 times negative 1. Answer goes up into the next column. That gives me positive 2. Then we add. So pretty much we're just repeating that process over and over again now. So negative 7 plus 2 is negative 5. Now I'm going to do the multiplication again. So take your value here, multiply it by the next number, write that up in the next column. Negative 2 times negative 5, positive 10. Again, careful with those negatives and positives as you do this. Let's add the next column. And one more time until we get to the end here. Negative 2 times 5 is negative 10. And then again, we're going to add that last column. That will give me negative 9. So right now we just have like a bunch of numbers. We need to figure out what these numbers are. So working our way right to left, opposite of how you read, this is the remainder. This is the constant. So I'm just going to use number for this, number by itself. This is the x term, x squared term, x cubed term. Okay, so my final quotient is going to be x cubed, 1x cubed, minus x squared, minus 5x, plus 5, and then the remainder is negative 9. Okay, so this says use synthetic division to divide, then write the multiplication statement that could be used to check. So how would we check that we get x to the 4 plus x to the 3 minus 7x squared minus 5x plus 1 with what we got there? What's the form to check? Keaton? Perfect. So that's our form to check. Things stop working again here. Okay, so I will say FOIL to check. It's not really FOIL anymore if it's not two binomials, but you guys get the idea. Okay, practice this on your homework if you're not like confident in your distributive property skills. That way, once you go to check on your test, you can make sure that you understand how to do that. Yeah, so that's a good point. So once we rearrange this into descending order, which we must do, you may notice here that we have an x cubed, x squared, but we're missing an x term. With synthetic division, I will not get the correct answer unless I put a 0 in the place of that x term. So 0 and then 1, because I'm going x cubed, x squared, I'm missing the x term, and then I go to 1 for the constant. What should I put over here if this is x minus b? Kenzie? 4. Okay, I'm going to give you guys a second. You try now. So this will be multiply and then add. Who can take me through the synthetic division process here? Nicholas? Perfect. So every process, so that's an important step to remember, right? Because if we don't remember to drop the first term, then we have nothing to sort of work with after that. 4 times 2 is 8. I add. 4 times 1 is 4. I add. 4 times 4 is 16. I add. And then I can work my way from right to left and find all the terms here. So this should be remainder always, the one on the right. Constant term, x squared term in this case. So our quotient should be 2x squared plus x plus 4, remainder 17. What's the format to check? Form to check your answer here, what would I write? Erie, what would you write?
1 minus 7x squared plus 2x cubed equals 2x squared plus x plus 4 plus 7.
Sure, or you can write it in descending order. Doesn't really matter. In the end, if we do this and we expand it out, we should end up with 1 minus 7x squared plus 2x cubed, or 2x cubed minus 7x squared plus 1. Same thing. Okay, we're going to just do this last one so that you guys know how to divide with synthetic division when you have a number in front of x, and then you guys will have more time to practice. So synthetic division when your binomial is in the form ax minus b. So in other words, I have a coefficient in front of x that is not equal to 1. What do I do in this scenario? Okay, so one thing that we sort of do is we get the binomial into this form where we have x plus something. And the way that I'm doing that here is I'm taking out the 2 from each term. And when I divide out this 2 from each term, I put it out front, and I have now x plus a half. And that means that my b value will be negative half. It's also the value that we have practiced with like zeros for x-intercepts for something like a term like this. So negative 1 over 2, it's like as if we set this equal to 0 and solve for x. But we sort of have to get this into a form where we have x plus a number, and then we can use that for synthetic division. So in this case, my b value will be that negative 1/2. And then I'm just going to write all the terms, make sure they're in descending order, write all the coefficient terms, 4, 8, negative 11, negative 14. I will add this column, and I will do the same multiplication as usual. Okay. Drop the first term, then multiply. So negative half times 4. In other words, if I'm multiplying by negative half, I'm taking 4 and I'm dividing by negative 2, right? Multiplication by negative half and division by negative 2, that's the same thing. So what's 4 divided by negative 2? Negative 2, write the answer up here. Okay, same process as before. So now that we have that, we're going to add. We will get 6, and then we will do the multiplication again. So 6 times negative half, or in other words, 6 divided by negative 2 is negative 3. Write the answer up here. Add, repeat the process again. So negative 11 plus negative 3, negative 14. One more time. Negative half times negative 14. Or what is negative 14 divided by negative 2? Matt? 7. And then add. Okay, there's a little trick with these ones. Because I did this, and I took out that 2 at the beginning, in order to get this x plus a half and then get my negative half. What you have to do is you're going to divide by this at the end. So whatever you had seen here, or in other words, whatever the denominator is here, that's what you're going to have to divide every term except the remainder by. So this is the remainder, that will stay the same. But every term here must be divided by whatever your denominator was here. So I need to actually divide every term here by 2 when I do division in this format where I have ax minus b. So I'm actually going to get 2, 3, and negative 7 with a remainder of negative 7. So that will be my remainder. And then I will work my way from the right to the left and decide, okay, I have a remainder. This will be my constant term. This will be my x term. And this will be my x squared term. Okay, so quotient should be 2x squared plus 3x minus 7 with a remainder of negative 7. Okay, let's practice quotient form for this. How would I state quotient form? Did you have a question? Yep. Yeah. How do I state quotient form this time? So rather than form to check, let's practice quotient form. Keaton?
So you have the 4x cubed plus 8x squared minus 11x minus 14 over 2x plus 1
Mm-hmm.
equals 2x squared plus 3x minus 7 minus 7 over 2x.
Great. That would be quotient form. Okay, so this is the key. You might want to highlight this for your future dumber self. Okay, divide by whatever that denominator was, every term except the remainder. Okay, so that is important. Do not divide the remainder. Maybe you can highlight that as well. Yeah, Rebecca.
Why are we doing that here but not in the ones before?
That's a good question. What's different about this one versus the ones that we did before? What's the main difference here? Vic? Yeah, so this time we have a coefficient in front of x. These times x was coefficient of 1. So this happens anytime I have a coefficient on x other than 1 when I use synthetic division. Andreas? Because of what happened up here. So we took out a 2 in order to get this. So I'm basically considering the fact that I divided out that 2. So I have to redivide that out with my quotient. Okay? Okay, so again, as a note, only linear divisors can we use synthetic division for. I cannot use synthetic division when I do not have something with an x to the exponent 1 going into my polynomial. Okay? That's why we learned about polynomial division, so that we can do other higher degree divisions. But synthetic division is really good if your divisor is linear. All right, so we have 15 minutes